Hey everybody, it's Dr. Schulman. I'm going to be going over 6A, which is geometry, the second part of it. Sorry I stopped the first one early. I just kept getting messages from my students in my statistics course, and they were struggling real hard. So that's why I closed that one early. But I hope you're excited. We're going to go into geometry. I thought I'd share some bit. I thought I'd teach a little bit first, and then we'll jump into it. So I'm going to share my screen. I know there's tons of tabs. Sorry about that. But the first thing I want to do is just how we can, we're going to do a lot of naming, but I want to do this little part again before we jump into the problems. We're still in 6A, but basically different dimensions, right? I just want to do a good job of explaining that and the names of shapes. So we can name shapes by their base, okay? Anytime we have a three-dimensional shape, we name it by the base, no matter what the base is. So whether it's a triangle, three angles, whether it's a square, and we'll learn more shapes as we go through it, whether it's a pentagon. I'm going to show you really cool things to do with the angles too. Hexagon. Sorry, my hexagon's ugly. Septagon or heptagon. They couldn't really decide what they wanted for the seven. 1, 2, 3, 4, 5, 6, 7. So I'm trying to make these as regular as I can. When they say regular, that means all sides are congruent. That's equal in size and shape. Octagon. So these should all be like the same size. And these are little hash marks that show how congruent they are. And then we've got the octagon, which is looks like a stop sign. And we have a decagon, which dec is 10, non is 9. And we'll learn more, like dodecagon is 20. But basically we always name it by the base, and then for 3D shapes, they're either going to be a prism or a pyramid. Nothing too crazy. So the prism means we have a flat top and a flat bottom. So basically, it's just built of rectangles. So they're made up of rectangles. So this is a triangular prism because it's made up of rectangles. And if I were to cut this thing up, guess what? Oops. If I were to cut up this thing, I'd have a triangle, and then I'd have 1, 2, 3, because we fold it all together to make it. Pyramid just has a flat bottom and a pointy top. And this is made by triangles. So this is made by rectangles. Like let's say we have a square on the bottom and it forms a triangle here, right? So this is a triangular, sorry, it's a square pyramid. And if we were to open this up, we have a square, and we have a boom. Sorry, mine looks a little more rectangular. But if we fold that up, we get it. Now, there's a bunch of other things too. So these sides are like we have like if we have a shape, right? These are all called the faces. This is called the base. A side is called an edge. And these like little corner things are called vertexes. And there's tons of words and terminology. I'm going to keep bringing them up as we go. I just thought I'd do a little intro. And a good way to think about dimensions, since we're talking about it, we will be talking about it, is 0 dimensions. A shape with no dimensions is a point. So this is a 0D shape. If we want to measure it, it'd be 0 centimeters. It just has a space and time, right? There's nothing here. But once we turn it into this is a line segment. Line segment CD, this is point C. Line segment CD is 1 dimension because we can just measure it from left to right or up to down. So there we go as a line segment. Other things with 1 dimensions, we have a line as well, line AB. We could have a ray, or we could have a line segment, like the one we have here. This one we're going to call 4 centimeters if we were to measure it. Now, if we bring it to 2 dimensions, that's when we can get an area. So CD. And in math, making more dimensions is just adding perpendicular lines which meet at a 90-degree angle. So this is our 2 dimensions shape, and there's our square. We're going to just say it's C, D, E, F. If it's a 4 by 4. If you were to count all these up, guess what? We'd have 16 boxes. So it's going to be 16 centimeters squared. We go to 3D. We're just building it out. I'm not the best at drawing in 3 dimensions, but here's my 4 attempt at a cube. So there's the cube, and if it's 4 by 4 by 4, we know it's 64 centimeters cubed. If you want to push your students to think in 4 dimensions, I have a really good lesson for that. You use pipe cleaners and you actually build. It's called the tesseract or the hypercube. Students like it because they used it in the Marvel movies, or I don't know if Marvel's cool anymore, but it used to be. So it's actually, it envelops itself. It's 4-dimensional shape. So out of each one of these, builds more. So that's a little bit of extra knowledge that I'm always happy to share. All right, let's jump into it. I just thought I'd share a little bit before we got back into what we're doing. Oh, and again, we are in Math for Teachers. I'm putting them all into one thing. And this is the first part of geometry. And we're doing length, area, perimeter, surface area, and volume. So we already did some areas. Let's do a volume. Let's do a new problem. All right, so answer all of them. So this is a 9 by 4 by 8. So we know it's 9 times 4 times 8. So we know the answer is 288 units cubed right away. This volume, area or surface area, you can think about it as painting the room. And volume, it's how much balloons will fill the room. So that's the real difference. So we're basically, no matter what we have, here's my student's book. So it'd be surface area would be like all of these sides, and you see there's 6 sides to this thing, and area would just be how much space is inside of it. So if we have this, shape, right? Nothing too crazy about it. So we know it's a rectangular box that's 288 because it's length times width times height. But if we're filling it up, if we actually open this thing up, you'll see, if we open this up, you're gonna see, I also need the top, right, and the right side. So ready? So there's your base, your bottom. There's your top. This is a side, a side, a side, a side, but you see how there's 6 of them? That's why it's 2 length width plus 2 length height plus 2 width height, and that gives you the surface area. So obviously there's nothing too crazy about this, but let's get into it. So there we go. So if we go across, we have 1, 2, 3, that's 9 right across. So we have 9 cubes right there. Let's keep filling it up. Oh. So now it's 9 times 4, which is 36. Let's see. And now they do the whole thing. So it's 9 times 4 times 8, which goes across, length, width, height. So we know it's 288. I'm pretty sure that was the answer. Ta-da. All right, let's keep this going. So let's do another volume. So here they don't give you this. A good way to help your students have them draw the picture. Drawing the picture helps. So what is the volume in cubic feet of a rectangular prism? So you notice how it says prism. That means we've got rectangles on all sides. If it said rectangular pyramid, it would have looked like kind of like that. All right, so it says it's 6 by 16 by 20. 6 times 2 is 12. Add the 0. 12 times 16, that's 0, 2, 7, 0 to hold the place because it's not just 1 times it, it's 10, 0, 1, 2. Our final answer is 1920 feet cubed. So don't be afraid to show your students the algebraic way or filling the shape. All right, circumference in terms of pi. So now we've got ourselves a circle. Circles and squares are actually really similar. Squares, you've got 90, 90, 90, 90, which is 360. You cut in half, you got a triangle. This is how we know the triangles are going to be 180, but a circle is also 360. But other things about a circle is that if I take this distance all the way around, which is called the circumference, and I multiply it by its diameter, gives me the area. Now there's this great video by Patterson that shows this, where he actually cuts it. If you want to look it up, just let me know. I can put it in Patterson circle area on YouTube. Patterson's one of my favorite geometry guys. He's just so smart. We just want Patterson's. I guess I got to go to YouTube first. It's not as famous as I thought. That's okay. So we got Patterson, geometry, circle area. And here it is. So if you want to watch this video, it's really cool.
Building your online business?
It's because he can show you how it actually turns into it from that shape. He's cutting the circle and he's just showing how the more times you cut it, the more length and width make it look like a rectangle. So there's your circumference times your diameter, which is going to give you a beautiful looking rectangle. Here, I'll put the link right here in case anybody wants it. But I think it's just really well done. I think it's just really well done. I'll put it over here in case anybody wants it. But I just think it's really cool how he shows how the area is their circumference times that piece. All right, so oh, sorry, that's the area. So the area is pi times the radius, so radius squared gives us that, or it's the so there's two formulas for a circle you really need to know. Circumference equals pi times diameter, circumference equals 2 pi times the radius, area equals pi r squared. That's what this video is. This is area equals pi r squared. Sorry, I was telling you the wrong one. I was having a moment. But I think it's really cool. It's really cool to see the breakdown of this one. It's the radius times itself times this distance around, which kind of gives you the formula. The area of the rectangle to get that. So that's pretty much what we have. Now, if you're curious how to get pi, this 3.14 constant, all you have to do is take the distance all the way around the circumference, and all we have to do is divide it by the diameter, because to get this by itself, we divide this by d. So that's what gives you this. So as long as you take the distance around divided by this, we get this special concept. And who would you have to thank for that? Srinivasa Ramanujan is one of the people who really went deep into pi and figuring out lots about it. Really smart. He was a menial clerk. He bagged groceries, and he couldn't finish high school because he couldn't do English. But he kept sending his journals out, and then his good friend Hardy, somebody at Oxford opened it, and they worked together, and it was really cool. There's a movie about him if you want to watch it, called The Man Who Knew Infinity. So let's do this simple problem. So we have the radius of a circle is 10 feet. We want to just, in terms of pi, oh, well, that's nice. So We want circumference equals 2 times pi times radius. Our radius is 10. So all we have to do is do 10 times 2 times pi. And we get 20 pi's, 20 pi feet. It's a distance around its a length, so that's why we don't have it. Another good thing about this Ramanujan guy, if you want, there's a great lesson where here's a great lesson you can think about using. We'll see it in the project-based learning lesson. And students use tape measures, rulers, and string to figure it out. They get to learn about them, which is cool. And they also get to take any objects. I was bringing like cymbals, big drums, really big things, and see how close they could get, how many digits of pi could they get in their answer. And then obviously I'd push them to use a compass because I'm always trying to get my students to use tools to find it. So feel free to always add some reading and writing into your lessons. It'd be great for your students. 10 pi. Oh, sorry, it's 20. Ta-da! Distance all the way around. Beautiful. All right, let's keep it going. A diameter is 15. Find the circumference to the nearest tenth. Okay, so we got to do some rounding. So basically, the circumference is 2 pi r, or pi times diameter. So basically, we have our diameter, and they want to multiply this by pi, 3.14. We're going to have to round right here. So our answer is going to be 15 times pi, wherever pi is hiding from me. There it is. We have 47.12. Let's see what we have to round it to. Nearest 10th. So this is the 10th place. This is the 100th place. As long as this is not bigger than 5, it stays the same. So it's 47.1. Ta-da! Oh, they want you to turn this to the radius first. I don't know why they're not having you use this formula. Now, another formula that we use a lot is this constant. We use tau a lot. And tau is great. It's like pi, but twice. So pi is like, so this is the circumference, not to the diameter, but to the radius. So if we put a tau here and an r, it'll work. So that's how you get the circumference divided by the radius. It's going to be tau, which is 6.28. It's a really good constant to teach your students about. We use it a lot. All right, level 2. Let's bring it up. All right, so now I get to work backwards. Circumference equals 2 pi r, or circumference equals pi d. A great lesson to do with circles to help students understand all the parts is you can have them design their own rims. It's really cool. So it says the circumference of a circle is 2 pi, find the diameter. So we need this one. The circumference equals pi times diameter. They know this is 2 pi equals pi times diameter. Now, it doesn't matter what you have on both sides. It could be a log, a ln, an integral sign. If it's the same on both, you're allowed to cross them out. So what are we left with? 2 equals diameter. You just have to do the formula backwards. I don't know why they keep using the, what's it called? The one formula, but we know there's 2 we can use. All right, let's do another perimeter. Okay, so now we've got a strange shape. Find the perimeter of the figure below. These happen all the time where you get strange shapes. I've made tons of exams and tests with these. I guess I'll give you some of them. I'll put some of them on this quiz. Where you've got a strange shape like this, you got to work with. They're really good questions. I just have to remind myself. That's what I want on your quiz, because you will see it on your licensure exam most likely, and it's just a good problem. So bear with me one moment while I find a better pen. Almost right here. Or you get to do some of these. All right, so this is obviously a tough one. Don't be too afraid of it. You can do the box minus the so we need the box but we're missing one side, right? And this is like the whole circle, but we want half of it. So I usually think about them as two shapes. I think about it as one shape that I'm gonna find. Then I think about it as this other piece that I'm also gonna find. I'm gonna add them together. Sometimes they're different. Sometimes they could put the circle on the outside. Sometimes they put a triangle here, whatever they put, but this is all you really need. So find the perimeter of it. So the perimeter is, well, we know there's 4 here. Oh, sorry. We know that it's 11, 11 plus 4. So that's 22 plus 4. So we already have 25 right here, right? 11 and 11 is 22. 22 plus 4 is not 25, it's 26. Almost made a stupid mistake before I started. So that's 11 plus 11 plus 4 is 26. Now, we know a whole circle. Now, this is the move. You take this chunk, you slide it over. So this piece gets slid here. So if I know that's 4, I know that's 4. We remember that circumference equals pi times diameter. We have the diameter here of 4. But do we have the whole circle? No, we want to take our answer and divide it by 2 at the end. Why? Because we only have half a circle. Think about it as the circumference equals 1/2 pi times diameter, whatever you want. But basically, we want it's going to be 4 times pi divided by 2. Well, what's 4 divided by 2? 2. So basically, this whole little chunk right here, that's just 2 pi. That's it. So 2 pi is 6.28. It's what tau is. I'm going to just do 2 decimals. So 26 plus 6.28. 26 plus 6.28 is 32.28, but they want to the nearest tenth, right? This is, guess what? Bigger than 5, so it's 32.3 is the answer. You're going to see ones like this a lot. And they're just really good for students to go. Ta-da! I'll see there's another shape. That now you gotta add, you got this whole piece and then you add one. You got parallelogram 5, 5, 4, 4, and then a piece. Just look at another shape, another parallelogram. Now we have a whole circle. A whole circle. So you're just, there's no divide by 2 here. All right. Hopefully that was useful. All right, let's do some areas. Now I should have showed you that video. Area equals pi times radius squared. Basically, because we have a circle and you cut it up and you open it up, you get this weird shape. The more you cut it. The more you cut it, the more it looks like a rectangle. And that's how we can get the pi r squared. Ta-da! Isn't that kind of cool? So area equals pi r squared. We got the radius. So area equals pi times 17 squared. 17 squared is not 17 times 2. It's 17 times 17. And that's what gives you this piece. 289. So we have 289 times pi. That's our final answer. They want it to, oh, they want it in terms of pi. So we're already done. I was gonna round it and stuff, but here we go. And that's how you can get the area of the circle. It fills up the space. That's what area does. Doesn't go around the circle, it fills it up. Now we're doing the same thing. We went to the nearest tenth, so area equals pi times 7 squared. So that's 49 pi. So all we have to do is take 49 and times it to 3.14, and you will get the right answer. Oops. 159.93. This is not bigger than 5, so we're going to be left with 153.9. Ta-da! Oh, they gave us the diameter, so we had to cut it in half first. All right, let's do another problem. All right, so area equals pi r squared. Now, they give us the diameter, which is from one side to the other. Diameter is just a special chord. What's a chord? A chord goes just from one side to the other. This one, it hits it at one place. That's a tangent, and it forms a little right angle. There's our tangent. If it's a chord that goes through the whole thing, we call it a secant. Those are the most of the parts that you really need to know. But diameter, half of that is your radius. So if we know that diameter is 23, we cut it in half. That gives us our radius. 11.5. Now we square it. And we just times it by pi. 11.5 times pi gives us our final answer. We want it to the nearest, it said whole number? It says whole number. So we have 415.47, but 0.4 doesn't make it any bigger. There's your final answer, 415 meters squared. Ta-da! You cut it in half, and it fills up the space. That's what we get. All right, so let's do another circumference one. Oh, so this one you can get both. So we'll see what we have. So, okay, this is something that you'll see a lot. Circumference. And we have area. Why am I using R? Because R is in both formulas. That's probably why they don't want you to use the diameter one, because R is in both formulas. So we know that the circumference of a circle is 12 pi. That's what they give us. So if we know that, we can get the radius, right? We can divide both sides by 2 pi. The pi's do what? Fall. The 2's fall. What's 12 divided by 2? 6. So we know our radius is 6. Now, because I have my radius now, I can fill this in. So even though they gave me the circumference formula, I can still find the area by solving for r and then dropping it in. So area equals, oh, we want in terms of pi, so it's pi times 6 squared. So our final answer is 36 pi's. Who's hungry? Ta-da! There was the division. We got the 6 for the radius. Then we put in the other one. All right, let's find the area of a strange old shape. Ooh, this one. This looks scary, right? I'm scared. So let's do it. We did the other one, which was perimeter. Here we go. That's 8. This is 5, and that's 20. Well, this is a parallelogram. A parallelogram is a quadrilateral, which means we have 4. But basically, it's just 4 sides, but both sides are equal. A special type one is a rhombus, which means all 4 are the same. That's a special type of parallelogram. Not a kite. This kites look like that. Not a kite. That could be a rhombus. But this would be 20, and that would be 20 for it to be a rhombus. All right, so area of a rectangle is length times width. So area of a parallelogram, because it's just like somebody sat on it, it's still length times width. So ours is going to be 20 times 8. So we don't need the 5. We do not need this 5. So we have 160. If the pen will work, sorry about that. So the area of the parallelogram is length times width, which is 8 times 20, which is 160. Cool. So now all I need is we have 2 parts of the circle. If I put them together, the whole circle. And I have a diameter of 8. So all I really need to do is pi times diameter. Diameter is 8. It's 8 times 3.14. Then all I have to do is add these 2 together. And I have a final answer. So 25.12 plus 160. We're left with 185.12. Round to the nearest tenth. Our final answer is just 185.1. Let's see if I did that right. Oh, what? Oh, yes. I didn't put the height. It's always base times height, so I made a mistake. I made a common mistake, so sorry about that. We never want, anytime we're doing area, we never want the slanty one. Even if we have a triangle, right? If we have a triangle and this is 6 and this is 8 and this is 4, we just want the ones to make the right angle. 1/2 base times height. We want a parallelogram. All we want is the ones that make the what? Right angle. 5 times 20. That was my mistake. All right, let's do another one. I'm sure that we got crazy ones. This one's easy. Let's do one with that as another one. Okay, so here we go. This one's a little bit harder. So it's 9 times 26. That's this one. This one we don't need because it's slanty. We never want the slanty one. We just want the ones that make a perfect 90 degrees spot. So it's 26 times 9. And see, look, we all make mistakes. 234. Now, do I have a whole circle? No, I have half the circle. So it's pi times diameter divided by 2. What's the diameter? It's this one, the 12, like it slid over. So it's pi times 12 divided by 2. It's pi times 6. 6 pi, it's just a circle. 6 times pi is going to the nearest tenth. It's 18.84, so it's just 18.8 plus 234. 252.8. 252.8. That's how you do this one. What? Okay. Oh, because it's area and it's circumference. Wow. Cool. I gotta slow down. So I got this part right, but it's the area. I did the what formula? I did the circumference formula and not the area formula. That's okay. Guess what? We can do it again. Not the easy one. Let's do one of the hard ones. Oh, this one looks crazy. I think I should do this one. Yeah. Oh, wait, what was it? This one's even harder. Let's do one of those ones with like 5 circles on it. Here we go. Cool. So then I'll do another parallelogram one. So we know this was that a square? So it's a square. So a square is 28 times 28. That's the middle. And then I'll do another one since I messed this up. 784. Now I have one circle. I have two circles. I have two circles here. So it's usually the area for a circle is pi r squared, but I have to double it because I have two of them. This is 28. So the radius or half of that is 14. 14 is the radius. So it's 2 times pi times 14 squared. 14 times 14 is 196 times pi times 2. All right, so without the circle, I have 1,231.50. So it's just 1,231.5, 1,231.5 plus 784. 2015.5. Ta-da. Sorry, it took me a couple of tries to get this right. They're tough. Mine looks just like theirs. There's the area of the square. There's the other piece. We put it together. Oh, let's do one more. Whatever one's next. This is an easy one, okay? It's 6. This one's just rectangle plus semicircle. So we know it's going to be length times width plus, so it's the box plus the half circle plus 1/2 pi r squared. Until it's been a while for me doing these. So it's 6 for the long side, but we don't have the height. I know this half is 2, so the whole thing has to be what? 4. We got to double it, so it's 24. Now this is 1/2, 2 squared. 1/2 times 2 squared is 1/2 times 4, which is just what? 2 pi. 24 plus 2 pi. Oh, but we got a round. Okay. 2 times pi, which is 6.28 plus 24. 30.3, because the 8 rounds up, 30.3. All right, hopefully that's enough of these for you to really know what you're doing. Beautiful, 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 beautiful. Same steps. All right, let's do some quads. So there's a ton of quadrilaterals. All right. Give you something. Quadrilateral symmetry chart. I think that's the one I want. No, this one's bad. Is this the one? This is a Patterson one. Yeah, because it's got this huge thing. So that one's cool, but we want a different quadrilateral one. If you want this one, let me know. I want the, that's the answers to that one. I want the whole quad one. So I'm just going to type in quads. Is this the one? Name the quadrilateral. Yeah, here we go. Nice. This is something good. This is the good chart. So how to separate them all. Nice. So here you go. I'll give you this one. Here's a quadrilateral one. It's a really good way to like understand the differences between all of them and how they fit in. There should be a little chart though. I'll look for the chart as well. I know this isn't like the full naming and we're doing lots of naming, but there's so much vocabulary in geometry. Please consider doing formula sheet vocab quizzes each week with your geometry classes. They will help out so much. There's the first half of the video. Let's put this one in. So this is naming quads. It's quad properties. I know I had this really cool chart though. So let's see if I have it. If not, I can look somewhere else. Is this it? It's the big chart. Meh, that one's not great. There it is. Haha. I will always find what I need. Does this have the big little chart? Yeah, there we go. This is the little chart that I think is great. This little tree you can use with your students. You got quads, traps, right traps, isosceles traps, quads, kites, a right kite, quad parallelogram. And what are your different parallelograms? Rhombus, rectangle, and you got this pretty chart to go along with it. This one is the better one. You get them both, but this one I think is better. You could obviously tell I've taught geometry tons and tons of times, just like I've taught algebra and algebra 2 and college algebra tons and tons of times. So quad property, we'll call this quad chart because that tree chart is what's up. And I might as well give you one more to help. I want the 3D one. Yeah. So this is really good, just for naming, and we'll see more of it. These are just some slides. My students really like this because they actually got to fold this into the shape. There was one extra stop when they printed it, and you got prisms, nets, surface area, pyramid, volume, everything I was talking about before, but these are the slides that go along with it. You can practice naming it. What is this one? It's a hexagonal pyramid. And then there's like a fun one. What did the taxi driver say to his daughter? And you can name the shapes. There's a little maze at the end. Oh, I just have the matching, no maze? Oh, that's okay. So here's just some extra pieces. I'll give you tons of just vocab as well, but I should make that one first. So this is naming 3D shapes. I got tons of stuff though. If you ever want more stuff, just let me know. All right, let's get into the problem. See, because they're not all the same, right? Which ones have all sides equal? You know, like these questions are tough, right? Stuff about kites is tough. Stuff about trapezoids is tough. You know, if I would just really take your time and like really look through these and try to understand what means what. All right, sorry, there was so much there. I got a little lost. That's okay. Fill in the sentence with most specifically. This one is a square, but a square is also a rectangle, and it's also, it's not a rhombus, but it's also, so we got a parallelogram, rectangle, square. They're all true, right? Most specifically a square, because why? Both, that's parallelogram, it is equilateral, all sides are equal measure, and all angles measure 90. I think that's the best decision for this one. Ooh, they got pretty things too. Wow. I like theirs. All right, let's do a couple more of these just for fun. This one, okay, this means this is equal. Oh, they're all different angles? What? This is a kite. We don't got a kite? We don't got a kite choice? So we just got to do a general quadrilateral, but this looks like a kite. Nope, it doesn't. It's not actually a kite. It's just a generic quadrilateral. No two sides are congruent or parallel. Yeah, let's go with it. Beautiful. Now let's try a couple more. So this is parallel, and the opposite sides are equal. This one equals this one equals this. So you would think it's a rectangle, right? You'd think it's a rectangle. but these are equal, these might not be. So that's why this is a parallelogram. Where are you? Both pairs are parallel. And the only one side is congruent. These could be different. They won't be, but they're not telling us that it is. All right, let's do one more. That's why you should fill out a chart, right? Because there's so much. Oh, when they use these word diagonals and stuff like that, a lot of times, like, I'll do one of these just for fun for you. Where are we at? Okay, we're here. So if I have a square, there's tons of stuff we can know about it, but these guys, these are called diagonals because they go diagonal. Not only do they cut these into 45s each, they also bisect each other. And they also are perpendicular. They also make right angles there. So we got right angles here, and we got right angles here. Isn't the square beautiful? All right. All we know is that I'm going rhombus. This looks like a rhombus to me. Opposite sides, exactly. All sides are equal measure, but that's all we have. So I'm going rhombus because they tell us nothing about the angles. So rhombus is like a square that somebody sat on. The sides are equal, but the angles are not equal. Wild, right? All right, we might as well do one more. Nice, 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 nice. All right. Last one is a square. I thought they'd give us a trapezoid or something crazy. Equilateral, equal angular. Equi means equal. Come on, give me a trap. Oh, is it a trap? It's so close to being a trapezoid. Could we just go with it anyway for fun? No, it's a general quadrilateral. I do not believe this is a trapezoid. Because these would have to be parallel and doesn't say it. Doesn't tell me they're parallel, so no trap for us. A trapezoid just has opposite sides parallel. One side's parallel, and one side isn't. That's what makes it a trap. All right, cool. Hopefully that was a lot. Sorry if it was too crazy. All right, let's do some parallelograms. Okay, so I guess this video is being longer than I wanted because I'm going to teach you one more new thing. I hope you're excited. So what I'm about to show you, hopefully you've stuck around. It's probably one of the most useful things about angles. So if I know a square, so we have square. Actually, I want to do this right. There's a lesson to go with it. So I know I put it in the bridge. So I'm going to add one more thing for you to look at, a lesson plan to look at. Oh, I put it in here. Sorry. I wanna show you this. The shape breakdown. Just trying to copy you. Breaking down a shape. This is a really great lesson plan. It's probably one of the better lessons I've made. I'll clean this up too. I'll make it look pretty. I'll make this one the second one. This is something you should really consider doing with your students. I think it's probably one of the best things that I have. So one of the best kind of lessons I made up. I just don't want to lose anything. So what do you do with your students? Students get, oh, sorry. Have students draw a square on a piece of blank paper, ask them to draw it as well, have students tell me everything they know about it. And then you break down the paper. Okay, so let's do it. So here we go. It's blank. Cool. So basically, we're gonna do sides. We'll do name, picture. I'm gonna need this whole thing. We're gonna do name, picture, sides. So number of sides. Total degrees. Interior angle. So that's one on the inside, like interior decorator. And exterior angle. That's like exit outside. Hopefully this is clear. If it's not, so this is a way, this is like kind of like a modeling activity where students get to build the formula. So the first thing we're going to do is we're going to give them a square. So I'd have them write this all down. I'd have them draw a square. Tell me everything they know about the shape. Hopefully they'll get to the point where it's 360 degrees, that it has 4 equal sides. You know, you can stop them whenever you want. They're fancy. They're 2 sets of parallel lines. That's what these lines mean, 2 sets of parallels. They could say that diagonals are perpendicular bisectors. They cut each other equally and cut in half. But all we really care about, we start with the square. Here's our picture. We know it has 4 sides. Total degrees is 90, 90, 90, 90. So that's 360. And an interior angle is what? 90. So if the interior angle is 90, and the exterior angle on the outside is going to be also 90. Because a straight line or a linear angle is always 180 degrees flat. That's what that means. So if the inside's 90, the outside has to be 90. Now, let's say we take our our square and we cut it. We take our square and we cut it. Now I have a triangle. There's my picture. I'm going to try to make them all regular. It's got 3 sides. Now, if this was 360, right? But I cut it in half, that makes these how much each? 180s. Now to get the interior angle, right? So if I have a triangle, right? If I have a triangle, we know it's 180, but I want to cut it into 3 equal angles. That's going to give me 60. So the inside is 60. My inside 60, it's an acute angle. It's thin. The outside has to be, well, what's 180 minus 60? 120. Okay, so we got to grow. We're growing our square. We can grow with as many triangles as we want. So let's go one more. Let's put another side on here. Here's a picture. So now I have a square, but I'm just going to drop a triangle on top. So I have a triangle here, and I have a square here. So I can cut this into a triangle. So look, 180. 180 times 3 is 0, 4. That's 24. So it's 540. So we call this one the pentagon. Five, 540. Now, if I cut the pentagon into how many sides does it have? What's 540 divided by 5? That's 108. So if the inside is 108, it's obtuse. Then this external one has to be acute, 72. And you can build your students up as high as you want, but let's go to hexagon and maybe you can see the pattern. I usually have them do like a dodecagon or something crazy. So here's our hexagon. I'm just gonna have a square. I'm gonna put a triangle on top and triangle on the bottom. It's not regular, but at least we can see it. How many triangles makes it? 1, 2, 3, 4. We just add another triangle to it. This is probably how your normal hexagons look. Well, we know we can cut it into 4 triangles. So it's 6 sides. 720, right? 540 plus 180. $720. We are going to divide this by how many sides? 1, 2, 3, 4, 5, 6. So 6 goes into 720 once, twice, 120 degrees. So if one of these is 120, the outside has to be 60. So I don't know if you can see the pattern of what we're doing. What we're doing is actually we're cutting things into triangles so we can get a general formula. This is S for sides. Total degrees is what? Well, we know it has to be 180 and S, right? But if I just do 3 times 180, I'm there, right? 4 times 180. Well, what's 3 times 180? Did we get it? 3 times 180? Too big, right? 4 times 180? Too big. So something's off. We can't just do 180 times S. The best way to think about it is what we're doing. We're cutting into triangles. So the least amount, this 3 has to give me this 180. So how do I make a 3 into a 1? How do I make a 3 into a 1? That's basically the formula. How does this 3 doing what to 3 turns it into 1? We subtract 2. That's the formula. It's 180. S minus 2 is total. So no matter what we use, let's use the 5. What is 5 minus 2 times 180? 540. It'll work no matter what. So this is the formula for total degrees. Now, if they want the angle, we just take what we got, and what did we do to it? We take this whole thing, I'll put a bracket around it, and we divide it by how many sides we got? 180 times S minus 2 divided by S. 540 divided by 5. 108. Now, what's the formula for the last one? Well, at the very end, all we did was what? We took 180 and we subtracted it. Minus, what was that? 108. We should get the 72. Boom. So the final thing is 180 minus bracket 180 times S minus 2 all over S. And there it is. You don't really need a bracket for this one. Here, I'm going to make this one neater. It's not that pretty. Oh, lost more than I bargained for. All right, so this one is the first formula. Here's your second formula, 180 times S minus 2 over S. And finally, 180 minus a bracket of 180 minus the whole thing we did. So I know that was a lot, but basically, anytime you got 4-side shapes, that equals 360. And you can use this to teach pretty much anything you like. So let's do this simple one. Just got a parallelogram right here. The opposite sides are equal. So this is X. This is 110. So they equal each other. Now, if I wanted the other side, if I were to slide that up, it's going to match 110. It's going to make that straight line, right? It's making a straight line. So 180 minus 110. Okay, one of the other ones is 70. If we add them all up, guess what? We got 2 triangles. So it's got to make 360. Boom. We're going to do tons of this stuff throughout the geometry lessons. Ta-da! Let's do another one. Oh, it's the same. Hoping for a tough one. All right, so here we go. So here's the other side. So 145 minus 180, we get 35. I guess that's all they're going to give us. Yeah, that's all they're going to give us. 15. It's a cute, it's small. The obtuse, the fatty, it's got to be 165, right? My adding was off. Yeah, cool. All right. Sweet. Surface area. So we're just painting the box. Nothing crazy. It's got how many sides? 6 sides. So I always think about it as we do each of them. So 6 times 1, this is how I do it. 6, you can use the formula if you want, 2LW plus 2LH plus 2WH, but this is what I do. 6 times 1, 6 times 3, 3 times 1. So I have 6, 18, and 3, and then I just double them. So I got 12 plus 36 plus 9. 21 plus 36 is 57. Notice that this is not cubed, it's squared because it's got them together. What? 36 plus 6. Oh, because 3 doubled is not 9, it's 6. Stupid mistake. All right, that's fine. Okay, we might as well just do it again. So 12, so that's 24 plus 2, which is 4, plus 6, which is 12. 40. Sorry, I made a mistake. I hate making stupid mistakes. All right. Here's a good one. Here's a definite good one we can do. So we've got a square pyramid. You want to, you can always open it. And this is called making the net, opening it up. It's 3 by 3. So I know the bottom is 9. I have 9 on the bottom. Now all I need is my triangle. Well, if I know this is 3 and this is 4, a box is base times height. So this one's 1/2 base times height. So 1/2 of 12, what's 12 divided by 2? 6. But how many 6s do I have? I have 1, 2, 3, 4. So it's basically 6 times 4 plus 9. 24 plus 9, because these are all 6 each. 6, 12, 18, 24 plus 9, 33. So practice these, have fun with them. You know, here's a new one. Is it all the same? Yeah, these are all the same. It's okay. All right, let's do a cylinder now. Now, if you have a cylinder, best way to think about a cylinder is a what? 2 circles and a rectangle. That's all it is. Isn't that nice? You only need 2 pieces for it. This is your rectangle, right? These are your circles. It's still, so it's just like before, it's base times height, but this base is a whole circle. So it's a base area times height. We know that the base of this thing is a circle. So to get the cylinder, all you need is, ready, this circle area, which we know is pi r squared, plus the rectangle. Now, the rectangle is kind of hard to think about. You have to think about this as like unfolding, like a piece of paper, right? Like a piece of paper unfolding. This is a really good way to visualize it. Rectangle, cylinder, circle top, circle bottom, rectangle. So we really have to think about what's the best way to figure out this formula, right? But we already know one part of this is the height. We already have the height. And now all we need is the circumference, because the circumference is the distance around it. So if we take the distance around it and multiply it by the height, we have the rectangle. So it's basically the area formula plus the what? Circumference formula. So it's area plus circumference times height. Isn't that wild? Pretty sure that's it. If I got it wrong, we'll figure it out together. But 8-kilometer height. And we know that this is, the radius is 3. So this is 3 squared, which is 9 pi's. That's for this one. And then we have 2 times 3 times pi. Well, 2 times 3 times pi is 6 pi's. times 8. So I have 48 pies plus 9 pies. Notice I'm keeping the pies for the end, for the surface area. Nine plus 48 is 57 times pi, and they want it to the nearest thousandth. So the thousandths is ready. I need 10, 100, 1,000. So I have to go one more. I have to go to the 10,000th place because this is the one I'm looking at. So all I have to do is take 57 and multiply it by pi. All right, so let's write it in. We have 179.0707. Is this bigger than 5? Oh, yes, it is. 179.071. That's your answer. Notice that I tried my best to show you how the formulas all kind of came together. I think that's the best way to do it, students. For any one of these shapes. Oops, 179.071. Notice it's squared because it's surface area. What? 3. All right, did I make a mistake? 2 pi r squared. Oh, I only did one of them. I only did one circle. So I actually did the volume. This is the volume formula. This is how much it would be to fill it. Now, why is it more to fill it than paint it? Who knows? Who knows? It's just the way that the cookie crumbles, but I'll do it their way. So, because we have a circle and a box, right? So it's got to be pi r squared, then it's 2 pi r times h, right? Isn't that what I have? 2 pi r h. And I did a combination. All right, so if I just did this and if I multiplied this, this is the volume formula. That gives you the volume. Because the volume for anything is the base area times height. That's how you get the volume. You can tell it's been a minute. But we're doing surface area, which we just have to paint it. So if we wanted the volume, it'd be, just so we know what the volume is, since we did everything but multiply the last two pieces. So it's 9 pi times 48 pi. Oh, it only did one at a time. Okay, so it's 9 pi, 9 times pi, times 48 times pi. This is the volume. Way bigger. So 4,263.966.9. So that would be the volume. But we just want this. This is our shape. So we already know what these are. 9 pi, 9 pi, and we're adding it so we can leave the pi's to the end. And then this is 2 pi r h, which we already got was 2 times 3, 6 pi times 8, 48 pi. So 18 plus 48, 66 times pi. There's the answer. All right, let's do another one. I got frustrated when I can't remember stuff. All right. So we might as well do both. We'll do the volume on one side, base area times height, and we're going to do the surface area on the other side, which is what? 2 pi r, because we have two circles, plus 2 pi r squared, because that's for two circles, and then 2 pi r h. Cool. So we might as well do this one. So it's 7 meters and a radius of 2. So the volume is pi r squared times its height. And our height is just the height. So forget this. This is off because it's just times the h. So this was me combining two formulas in my head. Well, I always admit when I make a mistake, of course. So I still got this wrong. I still got it wrong. Only looking at both formulas side by side doesn't make sense to me. All right, so here's our picture. We got 7. So we know that this is 2, and the height is 7. All right, let's do both. We're going to start with the volume here, which is the base area, which is pi r squared, which is 2 squared times pi, which is 4 pi. That's the area of the base times the height, which is 7. So the volume here would be 28 pi's. All right. Let's do the surface area. So that would be if we want to fill the cup or the cylinder. So the surface area is 2 times pi times 2 squared plus. So this is for the top and bottom circles. This is for the rectangle. So 2 squared is 4. So we have 4 pi, but we have 2 of them, 2 circles, so that's why we double it. So 8 pi is the area of both circles. They're both 4 pi each. Now we have to do 2 times pi times r times h. So this is 7 times 2. Yeah, because that's the distance around. If I unfold this thing, I get 2 pi r, the circumference. That's 1/2, and the other half is just the height. So let's do it. 2 times pi times 2. So that's a radius times 7. So 2 times 2 is 4. 4 times 7 is 28. 28 pi. So I have 8 plus 28 should be 36 pi. And if I get it wrong, guess what? We'll do it again. But that's what I got. 36 pi is the answer for this one that they wanted. There's the volume, there's the surface area. 36 times pi. I got 113.0973. Well, 113.097. Let's see if that's right. Ta-da! See, they said base times height as well. Smart. Nice. So they have 2 pi r squared plus base times height, but I put in the 2 pi r times h. I think it's better for students to see it, you know, base times circumference. Cool. Cool. All right, here's the last one. Ooh, this is a toughie. So when they say cross sections, we take, like, if I take this guy and I slice it, I get little rings. That's what it means to make a cross section. Solid is cut by a plane. Okay, so what is a plane? A plane is like think about a giant whiteboard floating in 2 dimensions. That's a plane. So a solid is cut by a plane that is perpendicular to its base. So a solid is cut by a plane that's it could look like this, forming a 2-dimensional cross section in the shape of a rectangle. So it's got to be like a rectangular pyramid. So this is what I think is happening. Cut this thing, we get a little rectangle. Which one can be it? I think we need a rectangular base. That's a triangular base. It's a triangle prism. This is a square prism. I think this works. This, we're just going to get a bunch of triangles. And this, we're going to get a bunch of circles. I'm going B. What a hard question. What? Oh, because it was cut that way. Because that's the base. All right, let's do a couple more of these. That was tough. The cube is pictured below. Select the type of cross section when the figure is cut parallel to the base. We're talking, we're making squares. It's got to be squares. Nice. All right, let's try another one. Forming a triangle. Okay, so now we're cutting this thing, we're making a triangle. If I cut this thing, cut by a, oh, this is why, it's cut by a plane parallel. So when they say parallel, that's why. The other one, the one I got wrong was perpendicular. So parallel to the base is kind of what I've been doing every time. That's why I got the other one wrong. So if I cut this one parallel to the base, I get a triangle. Nope. This is the base, these are the faces. This I get a pentagon. This I get a circle. This I get a circle. It's gotta be D. It's the only way to get rectangles. All right, let's do one more of these. Rectangular pyramid is pictured below. Select when it's cut by a plane containing its altitude. So altitude, when I use this word altitude, right? When I use the word altitude, that's boom, up and down. There's your altitude. It's kind of like the inside height. Select the type of cross-section from the figure. It's cut by a plane containing its altitude and perpendicular to the base. So this thing is cut that way. If I cut this way, if I put a piece of paper straight down through it, there's no way it's going to be a circle. I'm struggling between pentagon and triangle, but let's try it. Let's try triangle. Let's see what happens. Is it the pentagon? I don't know. It is a triangle. Nice. Oh, nice. This is what I was visualizing. It's just hard to kind of see it. One more. A solid is cut by a plane that is perpendicular to the base. So that's one like this. Up and down through it, not across, up and down. Forming a two-dimensional cross in the shape of a triangle. Triangular pyramid, right pentagonal, right triangular prism. So basically our choices are, is it going to be a pyramid or is it going to be a prism, flat? Forming it, so if we cut it down perpendicular to the base, we're going this one. We're going with this, the triangular prism. Oh, okay, so definitely try to visualize these. These are nice and tough. Perpendicular to the base. So there's the base, that's parallel. Perpendicular is up and down. I guess we're getting rectangles here. Yeah, so definitely take your time. It's hard to visualize it. You can use the poly pen and actually cut it. That'd be cool. Let's do. Sorry, get out of my way. All right, so I guess we just want a new one here. Let's do this pyramid. Let's go to cut. They let me copy but not cut. Okay. Let's do a polygon and let's build one and then cut it up. Let's do one of those triangular pyramids. I mean, let's do a triangular prism. All right, so I need what? Do I need 3 of them? That looks like it's gonna fold. Cool. So I just made this little guy, right? I can zoom in on him. All right, so let me cut this guy. I can move him any way I want, but I just want to show that when I cut him, if I go vertically, I get one shape. If I go horizontally, I get the other. I guess I gotta unfold it before I cut it. Let's undo that. Thought I had the ability to cut here. Well, this should at least help you visualize it, even though it doesn't want to let me cut it. Notice that they all kind of snap in. All right, so there's one, and this is it full, right? So let's cut this thing. Drawing tools. Where's my cut? Oh, we had a cut function. Here's a cut. I want to cut the whole thing. All right, let's try that again. Sweet. Nice. All right, so I think I cut that one right where I wanted to do parallel, and then I'll do a perpendicular one. And let's fold this up and let's see it. Oh, that is off. Okay, so it won't let me fold it because I cut it. Oh, that's so annoying. And I can't cut it once I folded it. That's kind of stressful. Well, that's one way. Let's undo some stuff. Let's cut it the other way. So if I do this way, I can cut it this way. Then I guess you're just gonna have to visualize what did that make. It's not the best. I think actually just constructing it by hand and cutting it would be the best way to do it for students, either cutting it up and down, which is perpendicular to the base, or horizontally, which is parallel to the base. Well, I hope this was a good video. I guess I got a little long-winded. My bad about that. I hope you learned a lot. I know I did a ton of stuff in here, but it's gonna get better. Because B has, what does B have? B has, we're doing tons of names. So I did lots of names before, but we're gonna keep, so it's naming, vocabulary, vocabulary, classifying, a little classification. Ready, let's go. Rectangle, right triangle. So this is what's called two sides are equal. So this is an isosceles right triangle. It's a scalene right triangle. This is a right kite. We're talking triangle, square, pentagon, hexagon, septagon, octagon, trapezoid, parallelogram, rhombus. Woo! It's like a shape menagerie, right? Then we got our circles. If we cut a circle in half, guess what? It's a semicircle. We can create our own, right? Yeah. So have fun with this. Let me know how I can help you best. I hope you learned a lot. Practice these, practice whatever ones you want, and get ready for the quiz after I go through all of them. Take care.